Hello everybody, welcome back, and we're going to wrap up 5.3 today. We're going to identify translations and stretches given the graph of a cube root function or square root function, and then we're going to write an equation for that function. And then we're going to also just solve some problems using those square root and cube root functions. So here we have a graph, and the first thing we want to do is check and see what function is represented. Is it cube root or square root? So here I can kind of recognize it's a cube root function, okay? And so that's the first thing I want to recognize, is just that it's a cube root function and not a square root function. So I'll just kind of write that down. That's going to be a cube root function here. Okay, so cube root of x. Then that's a terrible looking cube root. So then I want to see if there's any horizontal or vertical translations, and there's not, right? Because I have this inflection point right here at my origin, and so that tells me that it hasn't been shifted. Anywhere. I don't know what's happening to my pen right now. There we go. So it hasn't been shifted anywhere. My point of inflection is right there at the origin. Then I want to check for any kind of horizontal and vertical stretch. And so my mother function usually has, if I go over 1, it's going to go up 1. So in this case, my scale is 2 here. So if I go over 1 here, it goes up 2. So this stretch right here is 2. Because I normally go up by 1. So I need to multiply that vertical factor by 2. So we're going to call this, it's going to be a cube root of x. But we have to multiply that by 2. That's my vertical stretch out in front. And there's no transformations. We don't go left and right, up and down anywhere. So just my whole function is just going to be y equals 2 cube root of x. And that's it. Okay? All right. On to the next one here. What radical function is represented here is a square root function, right? So we have just a square root function here. It just kind of goes like this way, okay? And then I think the thing I'm going to look at here is this is a scale of 2 and 4 here. So if I go over 2, 4, if this is like my new origin right here, right? If I go over 2, 4, I go up 2 because this is a scale of 1, 2. So if I go over 4, up 2. And so the square root of 4 is 2. So that is my, if you think about your parent function, that is my parent function. Square root of 4 is 2. So if I go over 4, up 2. If I go over 9, I go up 3, and so forth. So there's no stretch here. Okay, so there's no stretch. So I want to see if we translate it, and I can tell that it's translated because this is not on the origin. Okay, so I can tell that I went over to the left 5, and so I want to take my square root function here, and I went to the left 5, so I'm going to add 5. Right? So I'm going to add 5. That means I'm shifting left 5, and then for my vertical translation, I went down 4, so I'm going to put my negative 4 out here. And so that is my finished product. Is just going to be y equals my square root of x plus 5 minus 4. And there's no stretch on that function at all. Okay? So this next one is a little bit trickier. I can tell that my point of inflection moved down here a little bit. Okay? So I am going to have a shift. I know it's a cube root function, so we're going to start with that. It's going to be a cube root function. So cube root of x. And then I want to kind of look and see if there's something I can recognize with a cube root. So right here, I notice that there's if this is my new origin right here, if I go over here, over this amount, I go up 2. 2 is a perfect root, right? So cube root of 8 is 2. Okay, so I'm going to come over here. I know the cube root of 8 is equal to 2. Well, the problem here is I only went over 2, right? So I went over 2, so I would have plugged in like the square root of 2 equals 2. And that doesn't work, right? So I'd have to multiply that inside by 4 in order to get an 8. Okay, if that makes sense. And so what I need to do is I need to take my cube root function here, and inside I'm going to multiply by a 4 in order to get that to be my proper, in this case it's actually called a compression, but it's like a stretch, okay? And then I know that I shift it down 2, so it's going to be a minus 2 out here. So this will be y equals the cube root of 4x minus 2. Now you can also just plug in some points to make sure you have the right one, right? Just plug in 4. I plug in 4 here. It's a cube root of 16 and minus 2, and that gives us kind of a weird number. Let's try to get one that we can actually. How about this one right here? If I plug in negative 2, that's going to give me y equals the cube root of negative 2 times 4 is negative 8 minus 2. So that would be y equals negative 2 minus 2, which is negative 4, and that's what we have right here. Okay, so you can kind of check your numbers there too. All right, so that's writing equations. Now let's look at some just applications. So looking out to sea, the visibility in miles from a certain spot off a cliff can be calculated using this function, where x is the height in feet above sea level. Sasha walks through elevations ranging from 5 feet to 40 feet above the sea level. Okay, so from way up here on the cliff to down here. What are the minimum and maximum distances that she'll be able to see? So we're going to go over here. We're going to plug this in here. So first of all, we have our distance of 5. We plug that in there. That'll be 1.5 times 5. Oh, sorry. And then that's going to be equal to, and I'm going to write my calculator out here. If I take my 1.5 times my 5, I should get 7.5, I believe. Yes. Okay, so square root of 7.5. And then my square root of 7.5, my calculator back up here again. My square root of 7.5 is going to be 2.7, about 2.7, I should put approximately equal to 2.7. So that's my distance when she's 5 feet off the cliff is about 2.7. So if you look over here, about 5 is going to be about 2.7. Now let's check and see how about 40 feet, right? So distance when she's 40 feet is going to be the square root of 1.5 times 40. And that will equal, so let's take our 1.5 times 40. Our 1.5 times our 40. And that's going to give us 60. So we're going to have the square root of 60 here. And that is going to be approximately equal to, I'll take the square root here. The square root of my answer is about 7.7. So approximately 7.7 is my distance at 40. Okay, so over here at 40, about 7.7. And that's the graph. It kind of goes, like a little curve. It's not a straight line necessarily. Okay. So here's a try it if you want to try this and see now if we're walking from elevations to 8 feet to 48 feet, what do we have? And so all we're going to do is going to take the same thing. We have, this time our distance is going to be at 8 feet. So we're going to take the distance at 1.5 times 8, calculate that guy. We're going to take our distance at 48 feet. Now let's calculate that guy, 1.5 times 48, and see what we get here. Okay, so we take, and this time I'm actually going to do something a little bit different. I'm just going to go square root of, and I'll put parentheses in there. It's going to go 1.5 times 8, and that gives me 3.5. I put about 3.5, so it's going to be approximately, whoops, wrong color, approximately 3.5 for my distance at 8. That one. And then let's take a peek at the 48 feet. Now I'll do the same thing. I'm just going to go square root, first of all, and then just put in parentheses 1.5 times 48. So this is an example, you guys, of showing your work. I'm doing the calculator doing the work, but I have it written down right here. Okay. So even though I'm putting in the calculator, I know what's happening right here. Okay. So this is about 8.5. Okay. So this is going to be approximately 8.5. So the distance at 48 feet is about 8.5. Okay. So you have a Google Classroom assignment in Excel in Google Classroom. This one just kind of summarizes what we've been learning about our stretches and shifts horizontally and vertically for our graphing. This kind of shows the relationship between all my parent functions. Okay. And then you have a Google Classroom assignment. It's going to be not a worksheet. I'm sorry about that. It is in Excel. And so I will fix that. This is going to be, oh, darn it. This should be an Excel, not a worksheet here. Oh my goodness. Can't seem to get it straight here. Here we go. Excel. There we go. You have an Excel. And so be sure to attach all of your work and all of your answers. And then I will see you guys in class soon. Thank you very much. Bye-bye.